Good morning, everyone. We will get started shortly as the room is filled with attendees. Please use the Zoom chat option to let us know which county you're joining us from so that we can get a better understanding of where our audiences are from this morning. Thank you all for being here. St. Johns County, Seminole County. Do we have some Panhandle folks in the area? Leon County, okay. Martin County, Indian River. Quite a broad view of audiences. Broward County, Polk County, Martin County, Boca, Miami-Dade, Alachua. Fantastic. It sounds like we have a very wide range of audiences. So again, if you are just joining us, we will begin in just about 1 minute. We are asking you to please use the chat feature to let us know where you're joining us from so we can get a better feel of who our audiences are this morning. We see Marion, Lake County, Sumter County, Apopka. It seems like we have representation from all over the state, from north, south, and central regions. So that's fantastic. So for the sake of respecting everyone's time, good morning again, and welcome to the Florida Friendly Landscaping Professional Webinar Series. My name is Mark Celestin, and I am the training coordinator for the Florida Friendly Landscaping Program. And we are excited to host you this morning. Your microphones have been muted. We will be closing the chat feature during the presentation. Please put your questions into the Q&A box, and we will take them at the end of the presentation. Again, this webinar is approved for 1 FFLCP, LIAF, FDAX, including LF, LCLM, LLO, CLO, and ornamental and turf, DBPR, NF and GLA CEUs. Please note that the 1 ISA and CAM CEUs are still pending approval. So if you would like assistance with those specific CEUs, please do not hesitate to get in contact with us. There is a $15 administration fee to receive a certificate for continuing education CEUs. We will put a link in the chat box to make payments for the certificate if you have not already done so. You'll also see a survey invitation pop up. Please take a moment to complete it. It is an important tool that helps us shape future educational programs and better serve upcoming audiences. We will submit for CEUs to the licensing agencies on Friday. So please make sure to finalize your CEU payments by the end of the day today if you would like CEU credits for your attendance. This is a part of a monthly webinar series that is held on the second Tuesday of every month at 10 a.m. Eastern Time. Our next regularly scheduled webinar will be May 12th with guest speakers Yiling Zhuang and Ondine Wells, who will present on the topic Advancing Water Efficient Landscaping in Florida, Barriers and Opportunities. So please mark your calendars. Today, we are thrilled to have you join us for our webinars on the topic of next generation landscape industry, robotics, automation, and AI in action, presented by our very own Dr. Bryan Unruh. Dr. Bryan Unruh is a professor in agronomy and associated director at the University of Florida, IFAS West Florida Research and Education Center in Jay, Florida. Dr. Unruh received his PhD from Iowa State University and his master's and bachelor's from Kansas State University. Dr. Unruh's Turfgrass Science program is at the forefront of developing and improving best management practices for all segments of the green industries. Results from his team's work are included in all 4 Florida turf industry BMP manuals. Unruh's team was selected to develop the Golf Course Superintendents Association of America, GCSAA, National BMP Planning Guide and template that resulted in golf-centric BMP manuals in all 50 states. Very impressive. Dr. Unruh was honored to receive the GCSAA's 2023 President's Award for Environmental Stewardship and the 2003 Mary Roberts Lifetime Service Award from the Florida Golf Course Superintendents Association. Dr. Unruh is a fellow in both the Crop Science Society of America and the American Society of Agronomy and was selected as the recipient of the 2024 Crop Science Society Educator Award. So without further ado, please help us in welcoming Dr. J. Bryan Unruh.
All right. Thanks, Mark.
Yes,
we need to update that bio a little bit. We now have 5 BMP manuals for the state of Florida. The sports turf BMP manual is, let's just say it's at press. If you do an internet search, you can actually find a Word document online, but that's not what we're going to talk about today. I usually do talk about BMPs, but I want to really spend some time talking about kind of the next generation landscape industry and really to focus on some robotics and some automation and a little bit of on the AI piece. And just kind of to give us a little bit of direction, I want to talk about this landscape equipment sustainability strategies, or the acrostic LESS. And we're going to do more with less. It's a big project that I've been part of for the last couple of years, and we're getting a lot of momentum behind that project. So I'm going to spend a little bit of time talking about just some of the things we're doing, and then spend some time towards the end, a little bit of time talking about artificial intelligence in the landscape industry and kind of where things are going with that. And so when we jump in, I want to, like I said, talk about this project that I've gotten myself involved with, innovations and insights into OPE. OPE stands for Outdoor Power Equipment. You see my name at the top. That's just because I'm giving this presentation, but really the kind of the brainchild behind all this is Dr. Paul Bartley at Auburn University, and his grad student Landon Erbrick, and then Mark Hoffman's another professor at Auburn, and then Julie Campbell from the University of Georgia. And so I want to kind of set the stage as to where we're going, and ultimately when we think about outdoor power equipment, and just kind of some of the trends that are going on in the business. And so I think we have to look, kind of pull this plane up and from really high and look at the green industry's impact. We know that in 2020, there was about an 80% shift, or about 80% of the US population lived in urban areas. And that is expected to increase to up towards to 90% by the year 2050. And that kind of amplifies the significance of green space. You know, we're kind of paving over and concreting over our cities, and these parks and these gardens and these lawns really become increasingly more important in the grand scheme of things. And ultimately, you know, from an agriculture, how are we going to feed everybody, and then how are we going to sustain everybody as well? Well, we know the green industry's impact when we think about environmental resilience. We know that green landscapes improve air quality by capturing pollutants and producing oxygen. We know the urban heat island effects are reduced when we have living plants in the landscape. We know that there's enhanced stormwater management by increasing infiltration, and that's increasingly more important as we continue to build streets and parking lots, and then obviously supporting urban biodiversity, habitat for wildlife, not just the big critters, but even the little critters. And then we know that human health and well-being, and this was really expressed, you know, kind of through that COVID era where people were spending a lot of time outside. And then we know economic advantages. And when we think about the green industry's impact nationally, it's about a $348 billion economic impact. We know nationally about 100,000 business establishments in the U.S. In the Southeast United States, roughly a fourth of those landscape businesses out of the 100,000 um, or landscapers in the Southeast. And we know in Florida, it's about a $42 billion economic contribution to the economy. Um, and so when we think about it, and we really saw this as we kind of moved through the global pandemic, we saw work from home tripled in that period of time. Now, a number of businesses and entities have kind of come back and required employees to come back. But we know from 2019 to 2021 that work from home tripled. And there are still significant sectors of the workforce that still work from home. And then we know that increased time at home brought kind of heightened attention to residential landscapes and even outdoor comfort. In that COVID era, the gardening boom. Gardening ranked as one of the most effective well-being activities. There was in that era between 2019 and 2021 about a 20% increase in new gardeners and about a 50% increase in DIY homeowner lawn tool spending, so that outdoor power equipment. And then we know professional landscape services rose about 6% as well. Now, driving a lot of this was this rising demand for battery powered equipment. And we know in 2021, about 72% of the 9.6 million leaf blowers that were shipped were, in fact, electric. Battery powered equipment surpassed gas powered in the market share by 2022. So we're seeing this significant shift towards this battery powered equipment. And we know that major retailers like the Home Depot have committed to 85% battery cells by 2028. And so we kind of have this changing public perception. And then we also have kind of some policy that is kind of following that or potentially leading some of that. We know that there's an estimated 121 million pieces of gas outdoor powered equipment deployed, and outdoor gas or gas outdoor powered equipment emissions are estimated to be about 25% of that of off-road emissions. Many of you have seen the blower or the string trimmer, and when the mosquitoes are bad, you mix the oil a little bit heavier so that you're fogging everything as you're going. Might not be good for mosquitoes, but it's definitely not good for you and me. 4% volatile organics, 12% carbon monoxide. We know that in Florida, the Florida emissions were estimated to be about 2.2 to 4.4 times greater than the state of California. And so the commercial versus residential equipment emissions remains challenging, kind of trying to decipher who's contributing. And so the truth is we really don't understand the potential negative impacts of landscape maintenance practices on state, regional, or even at the national scale. And so that has led to kind of some sweeping legislation across the country, as you can see in this map. And so there are places with the red pins that there's outright outdoor power equipment bans, there's future bans, there's restrictions placed on outdoor power equipment. Some places are incentivizing the conversion from a gas powered equipment to a battery powered equipment. And so we know about 200 municipalities in 17 states have enacted some sort of ban on gas outdoor power equipment. And so that leads us to believe about a fourth of the U.S. population could be affected by outdoor power equipment restrictions by 2027. And we know that 5 states, including the state of Florida, have actually passed preemption bills. And so at the state level, saying municipalities, counties, you can't pass rules and regs that are more restrictive than the state as well. And so, like I said, I've been involved in this, involved in this Auburn University, this Outdoor Power Equipment Consortium, or OPEC. Now, I jokingly say I probably would have named it something a little bit different in this, but when we think about advancing landscape innovations, and so this team of scientists are really measuring real-world performance, whether it's equated in runtime or energy consumption, looking at operational efficiencies, the costs, the durability, and then even perceptions of what's going on out there in the industry, and then looking at environmental impact, whether it's emissions or pollutions, and then what are potentially sustainable alternatives, and then can we kind of back that up with science. And so even looking at operator experience, whether it's the noise, whether it's the vibration, anybody that's ran a string trimmer for very long knows your arms start itching, and that's a result of some of that that vibration that's going on, and kind of what are the long-term impacts of that on the body. And so when we think about the industry as a whole, this kind of started out back in 2022, 2023, where my colleagues at Auburn conducted a survey sponsored by the National Association of Landscape Professionals. And this survey was distributed across kind of across the industry, and about 114 participants completed the survey. And the companies ranged anywhere from a single operator company to very large 4,000 employee companies. 30 to 100% of revenue generated from maintenance. So we weren't really looking at, it was kind of a subset of what was going on. Average years of operation. These were not young companies. These were companies that averaged 25 years and about 4,000 acres under management. And so we learned a lot about this, which is helping shape kind of the direction of this research. And ultimately, landscapers rank operational efficiency at the top. They want to know from a reliability standpoint, work capacity, and then the availability. Can they get parts for this? And then what is the maintenance required on this piece of equipment? The noise source, power source, and the noise pollution and the air pollution actually ranked quite a bit lower from the landscaper's perspective. Now, I'm going to counter that here in a bit with something a little bit different as well. So kind of key takeaways, we know about 52% of the participants employ battery-powered equipment, so roughly half. Now, I've been talking about this spring at different events across Florida, and Florida is considerably lower than this 52%, just, kind of a show of hands at some of these conferences that I've been speaking at. We do that noise influences adoption the greatest. And so noise pollution, the factors that led to battery powered equipment adoption. Noise pollution was a big one. Reliability, you put a battery in, assuming the battery has a charge, you pull the trigger, off it goes. I joke that weed eaters know how to fly. And people kind of look at me strange. And all of you that have ever ran a string trimmer, well, maybe not all, but you crank and crank and crank, and you pull, got a rotator cuff issue now, and you launch that string trimmer because the stupid thing won't start, the gas powered one. But we know with battery powered, assuming you have a charged battery, off it goes. The cost was at the least end of this, and is actually one of the barriers which is driving some of this work that we're doing. Overwhelmingly, the landscape industry tell us that they're really discouraged by what we're kind of defining as work capacity. Work capacity is it kind of correlates to run time. And I'll show you as we get into this some of the research that's going on to kind of quantify some of that as well. Power and quality could be kind of beta testing hangovers. In other words, a lot of the companies had kind of pushed some of this equipment out into the commercial industry, and maybe had some marketing claims that are there that was maybe a little oversold. Ease of use, safety, unfamiliarity with the equipment all factor into this, but not necessarily as great. And then the question was asked, if your concerns with battery-powered outdoor power equipment were addressed, would you consider adopting? And 70% of landscapers say absolutely. 15% say, well, we're not so sure about that. And then 15% outright said, no way. And so we kind of kicked over, and we've created a different survey, and we'll have a QR code here coming up, but Dr. Julie Campbell, she's at the University of Georgia. She's a professor, assistant professor of horticulture marketing, consumer behavior. And so this, we kind of went in and we knew what the professionals were doing. We wanted to kind of mimic the general population. And so we actually have a survey with about 1,300 consumers, and we just asked general questions about landscape knowledge and attitudes. And one of the questions is, have you noticed more battery-powered lawn equipment in the following places? And people are saying, yes, we do. We've noticed it in our neighborhoods. We see it in the city. When we're out traveling, not necessarily that they're observing it, but definitely in the box stores. So if you go to the box stores, Home Depot, Lowe's, Walmart, you practically trip over the displays when you come into the store because they have all of this, these displays up there trying to promote and sell battery powered equipment, especially now. And then your smaller stores, you're also seeing this, people are seeing this battery powered equipment. Concerns with equipment near home. And so again, we're asking people, what are these concerns? Appearance of the equipment, it's just not an issue. They don't care whether it's green or Ryobi yellow, green, whatever color that is, or red or orange or blue. Noise levels are starting to creep up there. Concerns, air pollution, maybe from the consumer perspective, it's up there as well. Environmental impact, but really it's the quality of work. Is can we get a good quality landscape from the equipment we're using? So then we kind of drilled in and started looking at comparison of battery versus gas powered, and it really came down to this piece here is good for heavy duty tasks. And basically the higher the number tells us that gas is better in this sense. And so when you think about good for heavy duty tasks, I mean, there's something testosterone driven. When you got this tree that you need to cut up, you don't want a little wimpy, battery powered chainsaw. You want, the Jethro saw that's going to, blow chips everywhere. Longer run times, familiar reliability, longer life of the power tool. But then we get down here and better for the environment. People are telling us that obviously the batteries are leading in that realm. And so consumers see battery tools mainly in the box stores. The messaging influences their willingness to hire providers. We're seeing companies now, not across the country, but even here in Florida now, that are moving towards full battery powered equipment. And then we're kind of leaning into getting a deeper understanding through some follow-up surveys, refining customer data for deeper insights, exploring differences across demographics and regions, and then provide the industry with some actionable marketing strategies. Again, there are companies out there that are actively marketing in that. I helped plan a conference a couple years ago in the southern states. We had a company representative, a guy that started a company up in the Portland, Seattle area. And 100%, I mean, this guy went all in, driving the Teslas, pulling the trailer, running the battery powered equipment, and doing a lot of marketing and reaching out to a specific clientele that is maybe more willing to pay for that type of service. And so there's a survey on the backside of this QR code. I encourage you to participate in that survey as you see fit. And so the first part of really doing any good research is understanding kind of knowledge and aspirations and of people and their attitudes, and then trying to figure out kind of where they stand and then shaping it and moving it forward. So I want to spend a little bit of time now talking about kind of some cutting edge technology. Landon Erbrick is the graduate student that worked on this project. He did a nice job looking at kind of assessing the return on investment and safety of autonomous mowers. Now, if you see that picture there, we're not talking about the small platform mowers that you typically see in the urban landscape. The smaller Husqvarnas or Sunseekers. We're talking full big mowers, and we'll delve into that here a little bit more. And so we know from the commercial landscape industry, when asked how concerned are you about the impact of each of these issues on your location's business in the next 3 years, 5 on the scale of 1 to 5, 5 is very concerned. High fuel prices, quality labor shortage, higher worker compensation costs. And these are the things that are leading this industry as well. And quality labor shortage is something that's not going away. In another survey, we asked, was asked, and it was published in Irrigation and Lighting magazine, what were your business's 2 largest expenses? Wages for benefits of all of the employees was way up there, 76%, followed by the equipment, tools, and material costs, and then just right below that at 33%, insurance, liability insurance, workers' comp insurance, and other coverage. The flip side of that is, what are your top three barriers to growing your business? Labor availability and retention. 71% of landscapers across the US are saying labor availability and retention, economic, and then right there at that number 3 point again is that insurance and employee compensation. So trying to find labor and then trying to pay them a fair wage. And so then that brings us kind of to this autonomous mower, some mowers that are going off and working. And again, these are not your small platform mowers like you typically see, the Husqvarnas and some of these. These are large platform big mowers, and they're designed to function without the need for an operator. Now they still require some human control and direction, and then they utilize technology such as GPS, vision-based cameras, as well as radar. And so, going to talk about some of these here. And so these are operated via, an app on the smartphone, and you can see that mower going across. There's nobody riding that mower, and you can see here we've did a bunch of work at the Auburn University on some of the intramural fields where we're going in and mowing these areas and quantifying their performance in that landscape. And so again, you can see you can literally remote control drive this thing, and generally that's how you're going to set this up, where you're going to go in and you may get on the mower physically, mow the boundary, and map it, and then once you close the circle, then that mower then goes off and does its thing on subsequent mowing as well. And so there's a bunch of marketing information out there on a lot of this equipment. Less time required. Now, these are potential benefits and then potential limitations. Less time. It's marketed as these are going to save you some time. The reallocation of labor, precise mowing patterns, increased efficiency, higher fuel efficiency on some of these autonomous type large platform mowers. And then the potential limitations are some sensor reliability, and I'm going to show you a little bit of the work that's been done there. The complexity of the landscape. As the landscape becomes more complex, then how do these mowers perform? Obstacle detection, and then ultimately the cost. And so this work that Landon did really was trying to determine effective return on investment on autonomous mowing equipment. And so just kind of the research that went in, there were these 1 acre plots that were established. And then we had manual battery powered mowers, manual gas powered mowers. So in other words, they had a physical operator on them. And then autonomous battery mower and a autonomous gas mower. So again, these were 1 acre squares. And then the plot 1 that you see there was no obstacles in place. And then in plot 2, there was some obstacles. There were 3. These are virtual obstacles. 3 areas that resembled a tree, and then there was this large T that the mower then had to traverse around. And so then went in and did a lot of quantification of fuel use, energy consumption, time it took to mow that plot. And so these, clicking along here, these are some of the mowers. These are the manual mowers, Gravely's and Stills, and then Bobcat, Mean Green, and Wright. And I want to just reiterate, these are 1,000-pound, 1,600-pound mowers. So these are kind of the big mowers. They're all in the range of a 60-inch cutting swath. Many of these, this one here had a 40 horsepower engine on it. And so these are big mowers, not those small ones. We did this work at a sod production farm in Foley, Alabama. And so you can see there were all these 27 acres of grass that were out there, 1 acre plots. And again, some of them had the obstacles, and then others did not. And so mowed a lot of grass, about 200 acres of grass over a 2-season period. And so I want to delve into a little bit of the data here. And you're going to see more of this coming out in some of the trade magazines as well. And so when we look at the energy consumption, and if I kind of set this up for the next few graphs, mower brands are going to be over here on the y-axis. So you Gravely, Stihl, Bobcat, Wright, and then the battery mowers are in orange, and the gas mowers are in blue. And then on the bar themselves, the orange bars are the just 1 square acre of grass, and then the blue bars are those with the obstacles. And so if you look at this here, when you convert the energy consumption from milliliters of gasoline to watt hours, you can see these, you see a huge difference between the two mower types. And so battery mowers, very short bars, but not a lot of difference between obstacles or free. But gas, we see a tremendous increase in consumption of energy. And the reason for this is that gasoline is a more raw energy form, and versus batteries. And I saw that a question popped up, but what is the pollution impact with dead batteries compared with gas tools? And that is not something we're looking at, but it is in the big picture needs to be considered. The other side of that is, the environmental impact of mining, the lithium and various things for all of these various batteries. Now, if we leave the mowers kind of in their respective units of energy, so watt hours and milliliters, we're really not seeing a whole lot of difference between these. And this kind of comparison would be equivalent to us comparing, say, miles per gallon on a gas car versus miles per gallon equivalent on an electric car. And that's the type of comparison landscape companies would use when making decisions to transition from gas to battery powered equipment based on how much fuel or how many batteries you would need to maintain a given property. And so this next graph, it shows all of our mowers combined and then sorted by manual up on top, and auto on the bottom, and battery in orange versus gas in blue. And if we focus on the three, I lost my place here. Focus on I clicked too many clicks. You focus on these here. Here we go. We can see that if we look at the gas mowers in blue, we can see that the gas autonomous mowers consumed much more energy than the gas manual mowers up here. And there's a number of reasons for that. First of all, per manufacturer's instructions, when you crank up the gas powered mower, you engage the blades. The instructions tell you to run that mower wide open, right? So that engine is wide open, whether you're mowing grass or transporting the mower or whatever, that engine is wide open. And so that's why you see this, whereas, say, the battery powered mower, it's all on demand. And so if that mower is sitting there, not mowing, not moving, no energy is being used. As you push the levers forward and off the mower goes, then there is a concomitant increase in power usage based on the wheels that are spinning. And as soon as you engage the blades, then it's using more energy as well. So engine's wide open, whether it's mowing or moving, you're burning energy. If we look at our gas mowers, we can see that the gas autonomous mowers consumed much more energy than the gas manual. And this is an interesting thing when we think about it. The auto mowers tend to kind of sneak up on obstacles, and whereas the human operated mower, operators are pretty darn good. And so as they're mowing around, especially as you become more familiar with the property, then your mowing pattern typically, you improve on that efficiency side significantly. And so when we look at time to cut, whether they're manual versus autonomous mowers, not a lot of differences in the manual, but then the auto mowers, and that was my point I made just a second ago, is that the auto mowers tend to sneak up on obstacles through these detection limits that are there. And so many of these results really directly correlate to time. And we didn't see any differences in the time to cut between all of our manual mowers, even when we throw obstacles into the plots. And so you notice these, and so these are manual mowers, so there's a human operating those mowers as well. when you look at the auto mowers, not only did they take much more time to complete the free plots, adding obstacles significantly increased the time even more by an average of about 9 minutes as well. One interesting thing to point out, though, is the mean green mower there in the middle, which is a battery powered autonomous. It took the same amount of time to cut as the gas autonomous. And so anyway, here we go. Um, so, but we just saw in the previous graph that it consumed much less energy. And again, that's because it applies energy on demand and there is no energy wasted, whereas the gas mowers are running at max RPMs even when it's unnecessary. Now, there are a lot of other factors that influence the time to cut for the autonomous mowers, again, such as slower turns. If you've watched an auto mower, whether it's a big one or a little one, they tend they're slower to turn, whereas most of the commercial landscapers that I watch, they're mowing at Mach 2 and they get to the end and they flip that mower around and off they go. A lot of times actually digging holes in the turf, which isn't a good idea. Wider overlap. And so a lot of the autonomous mowers tend to, and some of this is a programmable feature that overlap can be there, whereas the human operator that's running these knows, exactly where that overlap is, and off they go. And then the slower top speeds. Some of these autonomous mowers are governed such that they're going to slow these things down. And so it may seem like there's no case for auto mowers, but I think it's important to consider the benefits of allowing landscapers to complete other important tasks while the mower handles the monotony, potentially saving on labor costs. And I think that's one of the areas that this potentially shines when we think about it. So you have a crew of 2 or 3, and maybe that crew reduces down to a crew of 1. And so after that mower is set up, operator gets the mower off the trailer, puts it into the landscape, engages it, and then it's doing its mowing thing while then that same employee who's monitoring the operation of that mower is edging, string trimming, blowing the edges off, and then putting that mower back on. So again, it's more of this using that mower, that technology to expand that, because we go back to the surveys that are telling us that landscape companies are telling us finding labor is incredibly difficult, and then paying them a salary is incredibly difficult as well, or a wage. One of the things that comes up, if you're familiar with the small scale, robotic mowers that we typically see in the retail market, these things, if they get a little out of whack or run off course, then they bump into something and they eventually die. Whereas if you're running a 40 horsepower, 60-inch cut mower, what happens when something goes awry? And so we've been looking at it's clicking automatically when we look at this. Many of these mowers are now fitted with different RGB camera systems or radar systems to detect obstacles that are out there. And so we've done some research looking at whether that angle of approach is head on, whether it's at a turn and it encounters an obstacle, whether it's a 45-degree turn or even a 90-degree turn. And then the variables measured looked at human obstacles, whether they were an adult or a child, orientation, whether that adult or child was standing or prone, and then even the clothing. And we just simply did black versus white clothing. And so here we had some mannequins. So we have adult, full-size adult mannequins, and then child-size, infant, 2, 3-year-old size. And the research, again, was designed to expose the weaknesses within the tools. And this is really early stage of standard development. And the bottom line is the detection probability on some of the mowers was 94%. And so in other words, 94% of the time it detected an obstacle and then it paused and or shut itself down. And then some of the mowers are not as good. And so very interesting when we think about this, if you have any experience like with an EV electric vehicle, the Teslas, in fact, the graduate student that did this work um, owned the Tesla, and after his defense, we went to lunch and he drove, and it's the first time I'd ever ridden in a Tesla, and I'll tell you, I was impressed. We drove through campus, students everywhere. And the car was looking all these, a couple students stepped into the crosswalk, the car stopped. We pulled up to a stoplight. The car, I guess, looked both directions and then made a right on red. And then we got to the restaurant, and he pushed a button, and that car parked itself. And I can tell you, bottom line is that our mowers are not where Tesla is at the present time. But again, we're very early um, in this work, this technology, and so it's coming along. Just look at the advancements it's made in the EVs. Well, so we focused on large platform mowers, and again, this is pretty preliminary work. We're working on getting this published. You're going to see it showing up in different trade journal articles um, as well. But I want to look now at a little bit more of the handheld pieces in performance assessment. So I referenced Mark Hoffman, Dr. Mark Hoffman. He's a mechanical engineer at Auburn University, and doing some really cool work. And these guys are way smarter than me. I mean, they can do very complex math. I'll show you in a second. And so I showed you this a second ago that we have these outdoor power equipment bans. Most of these are pertaining to emissions, but then also noise comes into play. And so when we look at decibel dynamics, sound is measured in decibels, and it's a logarithmic scale. And so small increases equal big differences in perceived loudness. dBA or A-weighted decibels, that reflects our hearing sensitivity, and it's used in occupational and environmental noise assessments. NIOSH exposure limit is 85 decibels over an 8-hour period. And so we look at this, here's this 85 limit here, and then we can see, SEC football game 110, and then, 5-month-old crying is 70, and then coming down the line to no noise. And noise is contextual because the same sound level may be tolerable in a park, but if it's in a nice neighborhood that's quiet, it may stand out much more. And we know that gas-powered tools emit more low-frequency noise, which travels further and then it penetrates buildings more easily. And so then we also know that cumulative exposure matters. So when you add up kind of the riding mowers and the trimmers and the chainsaws, it contributes significantly to total daily noise. And probably the worst piece of power equipment out there, and you would know this if it were on a test, and that's the gas-powered backpack blower. And it's not just the gas-powered, it's also the battery-powered. And so we look at this gas-powered, the average dBA within 3 feet of that is 102.5. So we're well over that 85 threshold. So if you're an operator and you're not wearing earplugs or earmuffs and you're running this equipment, it's, the backpack's right on your back and your ears are what, 10 inches away. You are prone to have some significant hearing loss. But even at 50 feet away, which is kind of the other magical threshold, we're still right at that threshold. Now we can kick over to a big battery backpack. 3 foot is right at that threshold of 82.5, but even 50 feet away, we're still at 60 decibels. And so we hear those backpack blowers coming along, and we have a problem. Now, the mowers are a bit quieter. Now, if you're on the mower, physically on the mower, you're in excess on a gas-powered, say, Exmark laser, you're at 96.8. Even a battery-powered Gravely big mower, you're still above that 85 threshold mark. And a lot of that, it's not the engine that's making the noise, it's the blades and the whir of all of those blades. 50 feet away, you're down a little bit below that threshold. You're down to about 75 with the gas powered, but you're still at about 71 with that battery powered. And so I showed you this earlier. The survey, the industry folks are telling us they're overwhelmingly discouraged by work capacity. And then really, what is the true definition of that? And so power and quality, as we said, could be hangovers. And so one of the things when you think about work, power, or is when you think about battery, we know that there's half trigger, full trigger. I just bought a tool a couple weeks ago that's battery powered. Actually has a LED light at the trigger, and there's 1, 2, and 3 LED lights, and so you can fix it instead of kind of hold it with your finger at a half trigger. You literally can push that button and then pull that trigger all the way, and it's only going to deliver about a third, about 2/3, or full capacity. Whereas gas powered, it's variable. As you pull the trigger, you're ramping up and going down. Now, force tests have been put into place, and so this is really kind of cool to me as a guy that just grows grass. So they've got this gizmo in here, and they strap the blower to this cart, and then there's this round disc, this circular disc that measures force against that disc and runtime, and so allows then the testing of this various equipment. And what we see here is handheld blowers on the left and backpack blowers on the right. And you can see the top line there up at about 27, or this line here at about 20. Those are gas powered, and so there's a tremendous amount of force or velocity coming out of those blowers. And then the battery powered ones, not so much. And then we know, and you see this as the battery power is running along, and then all of a sudden when that battery dies, there's nothing, there's no output. Whereas as long as there's fuel in the tank on that gas powered backpack, that volume, that force is sustained over time. And smart people smarter than me, have done a lot of math, and they compute all of this using all these different equations as well. The other side, though, it's one thing to measure it up against that disc, but it's another thing to actually create kind of some test tracks. And so this was where we used 5 pounds of rubber mulch in a 30-foot walkway, and then had testing the different blowers. And one of the things, and you've seen this, there are some people that could blow a pile of leaves if their life depended upon it. And so the experience of that operator clearly comes into play. And so again, just quantifying some of this. And so when we look at break-even points on some of this equipment, these the slope lines here, the steeper slope lines, those are your 2 different gas-powered units. And then these battery powered, and you can see that break-even point or the return on that investment, it takes a lot more. And one of the things that we know when you run some of these, there's an economic factor, and there's another graph. This one I think shows it a little bit better. What this one is telling us here, this is the gas, and so your work output, as long as you keep putting fuel in it, the output keeps cruising. Whereas these battery powered ones, what it's telling us here, to kind of that break even point against the gas, it would take for this particular unit 2,883 recharges. This particular battery powered blower would take 5,541 recharges. These down here, 26, 3,500 recharges. Now, here's what's not often told you is that on a good day, a battery can handle about 2,000 recharges and then it's dead. And so what this is telling us that on several of these, you will never have a break-even point with these, simply because of the battery life. Now, one of the things I've learned in visiting with these engineers is that most batteries, almost all the batteries, are manufactured by the same 3 companies globally. But where the technology and the advancements are coming is in the chargers and in the logic that's built into the batteries and or into the equipment that controls recharge, temperature as well. And so we've seen, kind of these horror stories of houses burning down because of batteries. One of the things that I've learned through all this, even with a lot of my power tools, is make sure that you allow that battery to completely cool down. So if you take a battery out, don't slam it into the charger, have another battery put in there, let that one cool down, put it back in the charger. The other thing is, then when you think about this recharge rate, as ultimately, well, how do you get around it? As I said, you have to have more batteries. Well, these batteries are tremendously expensive. And then the batteries that tend to perform better for us are even more expensive as well. And then we get into kind of this charging Armageddon. And we've seen this nationally, a lot of debate about all of these AI centers and charging centers and a lot of energy. And when we think about implementing battery powered equipment into the commercial landscape industry, if you run out of gas, worst case scenario, you stop at the Wawa and refuel and get you a Coca-Cola and a burrito. I mean, whereas if you're running battery powered equipment, then you've got to have some way to be able to recharge that or have enough batteries that you can recharge when you get back to the facility at night. And so we've seen solar panel implementation on tops of trailers, but there's still a lot of concerns, and that's part of this project is we're actually looking at implementation into the commercial landscape business and to really quantify the economics of this. And so we've got to have some knowledge of our equipment usage, and understanding how and when that equipment operates is essential for cost-effective decision making. And that's where this research is taking us as well. Understanding equivalent energy requirements in transitioning to battery-powered equipment requires a clear grasp on energy consumption and recharge to ensure these seamless operations. Capital cost, I mean, so some of those big mowers that we're looking at there, those are $60,000 mowers. The autonomous battery-powered equipment, so that's 4 to 5 gas-powered equivalents. And then there's a bunch of unforeseen costs with inexpensive batteries, as we've talked about. And then get the best deal for the infrastructure capacity. And so again, these are things that we're working on. And so I know we've got a lot of questions. I'm going to spend just a few minutes. We were talking about kind of this transition over the AI side and where I kind of see some things going, and then we'll get into some questions. And so when you kind of look across AI in the green industry, we're at the infancy. And so there's some AI design tools, there's AI estimating and proposal automation. There's some tools now, scheduling, routing, crew optimization, and marketing and content creation. And so interestingly, when you look at AI landscape design and visualization, be curious through the chats or the Q&As to whether or not anybody's having any experience with any of this. But you literally can take a photo of a yard and then put it into a finished design. You can generate plant layouts, patios, lighting, irrigation zones, 3D renderings. It's pretty amazing, but there are some limitations. And I'll reiterate this, that they still, no matter how good AI gets, there's that human horticultural judgment that is needed. Plant recommendations. I mean, we see this even without AI. Plants get introduced into the landscape that have no business being into the landscape. It's kind of what was on sale, that was cheaper than maybe some other plant. But there's some cool. Some of these are actually at the surface level are free, and so kind of cool to play around with. Estimating proposal automation. So they auto generate itemized quotes, and offer some suggested pricing based on past jobs. Even just getting on the internet and doing you've probably been burned when you do the 50-mile drive-by estimate, and you don't look over the fence and realize that landscape was much bigger than you thought it was. And so now we're using Google imaging and stuff, and we can see into that. And so physically showing up isn't necessarily always required. I think it's still valuable. And so there's yard books and there's LMN, Jobber. And again, some of these are absolutely free to play around with. And then if you want some of the enhanced, and then many of them are automated so that you're doing not only your bidding and estimating in it, but you can also do some of your routing as well. And so again, here's an example, live job crew maps, and so you can see where your people are and optimize, which then when you think about fuel and time savings, driving to the job or from the job, we're not making money. That's costing us money. It's when we're on the job that we're making money. Adjusting schedules for weather delays. And I think from a BMP, I had to get that in because I'm the BMP guy, but we got weather delays. And we ought not be spreading fertilizer when it's raining. We ought not be spraying lawns when it's raining. And so balancing workloads as well. Marketing and content creation. This is really kind of cool. Before, after imaging, social media posts. There's some tools that we even use that can scrape our extension publications and then pulls out content that then becomes social media posts. It's pretty amazing. Website content, Google review responses. Zendesk is a tool that many of the questions that we get are repetitive. They're the same question asked by lots of people, and so AI can memorize what is the answer to that question that is asked so many times, and then it auto generates a response. This was just something simple. I used to pay $30 a year for a plant ID app because if you can't mow it, I don't know it. So I get a lot of questions. Well, what is this plant? If it's the grasses, I know them. But so I used to pay for an app. Well, now Google Lens is pretty amazing. So literally from your smartphone, that little app surprises me how many people don't know about this. And you mash that little click on that, and then it pops up, and you take a picture of what it is you're trying to identify. This one was an easy one, was the Southern Magnolia. Colleague of mine just showed me GoDaddy Arrow, I guess is how you say that. Literally, it's created a kind of the beginnings of a website that is completely AI generated. Now, here's the deal. If you're going to use AI, you've got to ground truth it. There has to be some fact checking that's done, because if AI will create all kinds of stuff. And so, again, it doesn't replace human horticultural knowledge or judgment. Many of the AI-based plant recommendations do not fully reflect local microclimates. And then we know for a fact AI chatbots are absolutely terrible for making pesticide recommendations. Do not do it. It will make stuff up. And so, you want to know, how do you kill, yellow wood sorrel, and it'll give you a list of pesticides. If you go look at the label, a bunch of them will be absolutely wrong. And we're starting to see the effects of that, where people are killing lawns because the chatbot told them to use a particular product to control a particular weed. And so I would steer clear of it for that. Now, that's not to say I haven't used the chatbots to read a label for me. And I'll use a keyword, a particular herbicide, and then I'll put in the word Bermuda grass in the label to see if it is, but I'm ground truthing it, I'm checking it as well. So with that, I think we have a pile of questions. Mark, you want to?
Absolutely. Thank you so much, Dr. Unruh. We still have maybe 2 minutes for one or two questions. So one of the first ones here reads, are there any current studies exploring pollution impact and energy consumption comparison with gas power versus the proposed alternative energy source?
Yeah, this research that I have been discussing here, that is exactly what we're doing. And like I said, we're starting to publish that. You're going to see it in trade magazines, like the Florida Turf Digest, Landscape and Lawn Contractors magazines. And so we're just finished that kind of first phase of research, and you're going to see it coming.
Thank you. Thank you for that response. We have another question here. Is it recommended to run these mowers on dry days only? And if not, which autonomous mower works best on slopes or wet slope surfaces?
So these big platform mowers that I had in this presentation, these big 30, 40 horsepower, 60-inch mowers, if it's raining, you don't want to be running those just because the soils are wet, they're heavy. Now, the small autonomous mowers, the Husqvarnas, the things like that, they rain or shine. And we've done a lot of work on those small platform units. They mow very well. They don't weigh a lot, so they're not going to be tracking up the landscape. We are seeing kind of in the older generation, you kind of get what you pay for. And so, the $300 auto mower that you're going to find, on the internet, we're finding that they're very lightweight. They do not perform nearly as well as your more robust mowers. We know that on St. Augustine grass, it's really tall and puffy. Some of these mowers don't, the small platform mowers do not have enough weight in them. And so on those really thatchy, squishy lawns, they don't do as well. Sloped, we've not seen, we've mowed slopes with them. They tend to do fine. They tend to some of the old style on those small platform, you'd put a wire around the perimeter of the lawn and then it kind of corralled the mower. The new mowers are RTK, real-time kinetics. So they're coming off a GPS. Those track pretty darn well. Now on some of the old wire ones, we had a slope and that mower would tend to kind of walk that slope a little bit. Still mowed everything. It just, you had more curved lines as opposed to nice straight lines. And so if you're into nice straight lines, the newer mowers, the RTKs are definitely much better. There's a question there about the ability, like robotic vacuum cleaners, for example, to detect obstacles. Yeah, the small platform mowers detect anything. It's more of a feel. They're not radar looking at things. If they even the slight bump, they're going to back up and go in a different direction. The big mowers, as I showed in the slides, the optical detections that are there, cameras and sensors, they're improving dramatically, but there's a lot of variability in that technology.
Thank you so much, Dr. Unruh, and thank you to all of the participants for joining us. We are actually out of time for the sake of the webinar. We hope to hear from you again. You do have Dr. Unruh's access. If you have specific questions, please do not hesitate to reach out. You can find him anywhere on the UF IFAS Extension web pages. So with that, Dr. Unruh, if you don't have anything else, thank you so much for your time.
Thanks for having me.
Yeah, take care.